our next expert, respected Dr. Hemant Kulkarni sir. Sir is academician and researcher with over 25 years of teaching experience. He is currently serving as the chairman of Research and Development Committee at Krantivir Vasantrao Narayanrao Naik Samsthat, Loknete Gopinathji Munde Institute of Engineering, Education and Research, Nasik. Dr. Kulkarni sir holds prestigious membership in several professional organizations such as Fellow Member of Institute of Engineers, Member of IEEE, Life Member of ISPE, Life Member of IAPMG. Talking about his education qualification, Sir has completed PhD in Electrical Engineering from Government College Amravati, MTech in Electrical Power System from DJIT Mumbai. Dr. Hemant Kulkarni sir has a research career in academia and has worked at multiple institutions like Finolex Academy of Management and Technology, Ratnagiri, as an associate professor at Sandeep Foundation, as a chairman of Research and Development Committee at LOGMIEER. Dr. Hemant Kulkarni has made significant contribution to the field of research and innovation. He published 5 patents from which he have been granted. He published 37 research papers in both national and international journals. He presented 13 papers at IEEE conference. He was monitored of 48 students for 37 days at KVK University, Lithuania. Sir also been involved in consultancy work such as installation and commissioning of 100 kWp solar power plant which conducted at Sandeep Foundation campus. Dr. Hemant Kulkarni's dedication to the education, research and innovation makes him a distinguished member of academic and professional community. Today, Sir is sharing knowledge on topic impact of renewable energy sources on power quality. So I request Dr. Hemant Kulkarni sir to please start the session. Over to you, sir.
Yes, thank you, ma'am, for a detailed brief and all the information you have given about me. Uh, so, just a minute, I will try to share my presentation. Yes, I think it is visible now.
Yes, sir.
Yes, sir.
Okay, so first of all, I am very much thankful to the management of Sir Dr. M.S. Gosavi Polytechnic Institute, the respected Dr. Principal Ma'am, and all other committee members for sharing my views on the impact of renewable energy penetration or integration on the power quality. So, uh, why we are moving towards the renewable energy? That is the first part. There are so many discussions going on that renewable energy, when we are discussing the sources, whatever different sources are available, the conventional sources and non-conventional sources. So every energy sector which is changing significantly to mitigate the climate change. And in mitigating this climate change, they are continuously trying to reduce the carbon emission, even in case of the transportation sector also, so in case of the energy sector also. So there are several advantages about the renewable energy. The renewable energy sources are abundant and they are freely available to us. Then the reduction of greenhouse emission is possible with the help of this renewable energy sources. And expansion of the available energy that is possible with the help of these renewable energy sources. Hence, we are considering that we will move towards the renewable energy generation or renewable energy sources we will use for the electrical energy generation. Now, uh, at very first step, I am going to ask you that which renewable energy source has the highest installed capacity in India? You can say about Maharashtra also. If you can unmute yourself and you can say, otherwise you can put it in chat box also. That what are the yes? I am expecting some answers. Okay, so we know that majorly now the just earlier session which you may have attended. I was going through that and I attended it, and during that period I understand that together he was discussing about, because he is from the practical field, he was discussing about the grid failure in the Gujarat, some part of Madhya Pradesh, and that was affected towards the Rajasthan also. And major problem was the crunch of energy we have seen towards the Nasik and Maharashtra region. Some part of Maharashtra was also affected. So that's why, say, listening him, I have added this slide in the presentation, that the renewable energy, though we are trying to show these two factors which are supposed to be solar and wind, we should understand that this is the major grid combination which is playing major role in that. So the available energy, the generation of energy, and how that is affecting to the power quality, that we are going to discuss. So what exactly the power quality means? So we have seen renewable energy. There are so many renewable energy sources, so many renewable energy sources which we have discussed, or we know. Now we are moving towards the what exactly the power quality means and what is power quality. What is power quality? So in simple words, we can say that the figure 2, which is a good quality sine wave, and power quality, I am trying to define it into the four parts A, B, C, D in the given waveform. You can see that in this A part, which shows you the amplitude. So the stability in voltage RMS value, that gives you the amplitude. Then the continuity part I am trying to show by B. This starts from this point to this point, and we are considering that it is the B part which shows the continuity. No interruption to the waveform. There is no any interruption in this waveform. Even there is no any what we can say that external noise added in this. So it's a smooth waveform. So no interruption in the waveform. So that is continuity. Then waveform shape is clean, not distorted. So we can say that the clean waveform means there is no any noise inserted in that. It means the waveform is very clean. And the fourth one, that is frequency, which is say D part. I'm starting from this to this, so it is one cycle normally we consider it as, and the stability in terms of providing the same range of frequency value. So that whole A, B, C, D components when you are getting, then we consider that it's a quality waveform, or we can say that good quality sine wave. We can define the power quality in different ways. There is one definition given by IEEE. So many definitions which you might have gone through. The power quality is the degree to which the voltage, frequency, and waveform of the power supply system conform to established specifications. That is nothing but the power quality. The power quality standards serve as guidelines for measuring and evaluating the quality of the electrical power supply. They provide guidelines for evaluating and enhancing the quality of the electrical power. So this is a rough idea about, or I'm not saying why I'm saying rough, because it is not as per the standard book language, but these are the common considerations for the power quality. Now here I am trying to show you that how the we can ensure the reliable power quality for optimum equipment performance. So what are the different parameters which we consider? The voltage parameters, then the phase synchronization, then the equipment functionality, that will be getting affected if the power quality is not good. Then the performance loss prevention. If I am getting any good performance for any machine, and if I am not providing the quality power, then definitely the performance of that machine will get affected. Then the consumer safety, which is very important in terms of the utilization of electrical energy, and also from the say, generation company, distribution company, and transmission company. Everybody wants that the consumer safety is a prime part. So they have to ensure this part. Now there are certain standards for the power quality. Power quality standards, there are say 61000 is a common standard, and there are different aspects with help of which we can consider that which is used at which place. So few we will try to discuss. First, international power quality standard, that is IEC 61000-4-30. It is related to the international standard stipulating how to measure the power quality. How to measure the power quality. I will show you here. So in this case, these are the standards, international power quality standards, and what it says IC 61000-4-30. It says that the standard measurement methods, then the instrument capabilities, then there are certain classes. So class A requirement and class S. So there are some variations, class A and class S requirement. So this thing is coming under this IEC 61000-4-30. Now in IEC 61000-4-7, it says about the harmonic. So harmonic current measurement, harmonic voltage measurement, equipment emission measurement, and instrument performance is totally taken care in case of IEC 61000-4-7. Now the next standards, that IEC 61000-4-15, we got that the standard defines the testing technique for voltage flicker. So it is related to flicker 61000-4-15. It works on, or it gives you idea about the flicker. What flicker means? Flicker means the uh, voltage fluctuation. That is nothing but the voltage fluctuation. Flicker measurement and voltage fluctuation. These two things are taken care in case of the IEC standard 61000-4-15. Now there is a European standard EN 50160 that is related to the power quality, that defines the limit value, for supply voltage and other characteristics. And this also can be seen over here, that IEC 610, that is related to the voltage flicker, that is voltage fluctuation. Then the European standard 50160, that sets the limit values for supply voltage and power quality characteristics in Europe. Okay, so that is the European standard. IEEE 1159, normally we are discussing this, normally we are teaching this part to the students also, that provide guidelines for monitoring and assessing power quality. And IEEE 519, which is very common, that addresses the issues related to voltage and current harmony. Those are addressing the issues related to the voltage and current harmony. So IEEE 519 is totally taking care of this harmonic part. Okay. Now, see, we have seen renewable energy sources. We have seen what is power quality. Then we have seen what are the power quality standards. Now, we will try to discuss about the all India level. Hello. Okay. So we are trying to get that all India level capacity addition as on say 31st January 2025. What energy we are trying to add. Okay. So in this case, what we are getting, we are understanding that this coal, the coal is having 47.29%. If you are thinking that coal energy generated, that is 100%, then the coal is the part of coal, or coal is contributing 47.29, and renewable energy is contributing 45.51%. Okay, I'm talking about up to 31st January 2025. Then the small part which is taken care by the diesel, nuclear is also 1.75%, gas is around about 5.27%, 32%, and diesel is about 0.13%. Then there are some other parts also. We can say that from the energy transfer from Bhutan and all that. Then we are getting that small hydro. Hydro is also, they are divided as a small hydro, then large hydro, then wind, biomass energy, solar part is major, and then large hydro part is somewhere. Okay. So from this figure, it is very clear that this contribution of coal is 47, and contribution of renewable energy. Renewable energy is in combination with say wind, small hydro, large hydro, solar, biomass, etc. etc. So if you combine all those, then that is 45.51%. Okay. I'm trying to show you this because we are thinking that in future, say we normally say that in 2030, what will happen? How our targets are. Already we have decided that how much energy will be generated by the renewable energy sources, how much energy will be generated by the conventional sources. So renewable energy sources we want to improve. We want to increase the energy generated with help of renewable energy sources. Now, what are the renewable energy sources? There are so many methods to generate, or there are so many renewable energy sources. What are those? So, hydroelectric, we have already discussed that small and large hydroelectric power stations. Then, wave energy and tidal energy. Now, wave energy and tidal energy is normally this tidal energy naturally it is at the seashores. So, I think in Chennai you can find it out that their power plant is there, but it is generating very less power. Wave energy is also in nearby the Kanyakumari, or you will find it out at nearby the Chennai or Bangalore. These plants are there in next to Bangalore. The wave energy generation they are trying to use. Then solar energy is very common. We are using solar energy at every part of the country. Then biomass and geothermal, their contribution is less. They are also considered under the renewable energy sources, but their contribution in generating or in giving the energy is bit less. Then wind energy. There are so many reasons, but and then next one is wind energy. So wind energy, you can find it out that the energy, solar and wind energy, these are the very common methods which we are adopting in India. Maximum energy generation is with help of solar energy, and then we can say that wind energy. The south portion maximum they are using the different kind of energy sources, renewable energy sources. But if we look into the Gujarat and Rajasthan, you will find it out that the solar and wind energy generation by using this renewable energy generation is very high with them. Okay. Now as I was going through the Central Electricity Authority data, they are providing this whole data in the Excel format, and you can have this type of structure with help of this. So this pie chart and this you can prepare with help of that. So why I am saying this, because they have given a huge amount of data which we can work. So April to January 2025, renewable energy cumulative generation. If we go through the region wise, then northern region is 38.16%. Western region is 24.17%, and southern region is 31.68%. Okay, eastern region is less 3.81%, and northeast that is having 2.18%. Okay, they are having some geographical problems that the area which is not suitable for using solar or wind, and that's why they are generating less. The in the month of January 2025, the same part, that is renewable energy generation region wise, can be considered as 30.01%, then 29.30% in the western region, and in the southern region it is 36.20%. Now, if I compare, see from this, we are getting an idea that okay, we are using proper renewable energy sources. We are trying to generate maximum energy with help of renewable energy sources. And the renewable energy capacity addition, if you compare, now this is capacity addition. We are trying to add the capacity. So in January 24, it was 1248 megawatts, and in December 24, it goes to 3924 megawatts. Okay, and in the January 25, it is getting 2726 megawatt. What we are understanding out of this, that though in January 24 to December 24 there is a change, there is a huge change, but in comparison with January 24 and January 25, in 1 year the capacity addition is not that much. And if we compare then December 24 and January 24, the capacity addition is less, renewable energy capacity addition is less. So this will give a detailed idea that which source is installed. So the addition in renewable energy installed capacity in January 2025 in megawatt, that can be considered. See, this is wind, this is wind, then this is solar. So capacity addition in January 25 we are talking about. In January 25, the capacity addition for solar is this much, for wind is this much only. Then for bio, small hydro, large hydro, and others, they are bit lower than that. Okay. So this is the overall RE capacity addition in January 2025. Now, when we are trying to impart this solar energy and wind energy, the power quality challenges, there are so many power quality challenges which we are facing. Okay, so how those can be, that I am trying to show you here, that if you are trying to solar energy from the urban grids and the wind energy from the rural power system, then you want to run your power system without making, or say, without creating any problems. But whether it is possible or not, or what challenges you have to face. Before that, we will try to find it out that the renewable energy capacity addition in 23-24 and 24-25. Okay, so this is about the installed capacity addition. This is nothing but the installed capacity addition from April to January 2025. April 24 to January 25, we have all the data. So this green line, okay, which is not dark, this green line, which shows that the total capacity addition, installed capacity addition in 23-24, and the thick dark line, or dark green line, it shows that the installed capacity addition in 24-25, in the same month, in the same month. For the February and for March, that addition is not available now. Up to January 25 only the data is available. Okay, and this data is freely available with the Central Electricity Authority. They try to work on that and they provide the data. Even they are trying to provide you the generation, live generation data. Means at this moment, what is the capacity addition in the location, maybe the solar or wind farm. Yeah. Now, the solar installed capacity, if you compare, then the solar installed capacity in the same way, say how the solar installed capacity is changing from 23-24 to 24-25. That can be seen here. Okay. Here you can see that how in April 23, April 24, what was the situation and how it is changing step by step. And you can find it out that in January 24, January 25, how the change is there. So this blue is showing you the wind installed capacity in 24-25. Yeah. After getting this, so before moving towards this part, I will try to ask you one small question, that considering this all installed capacity additions, what do you understand or what do you think that how much energy generation may be shared by the renewable energy sources in terms of energy? Energy means I am trying to discuss about the billing units. How many units you are thinking that how many units may be generated. So if this solar and wind, they are, this much change is there in their installed capacity. Installed capacity, we are trying to increase it. From this figure itself, it can be achieved, or it can be seen that there is a huge addition in the installed capacity. So but the fact which I got, that is from January 2025. In January 25, the thermal energy which we are trying to generate. So the energy generation with the help of thermal power is 77.35%. I hope you are understanding this. That though up till now I have shown you that there are so many methods with the help of which we can increase the generation. We are increasing the renewable energy sources. We are increasing the capacity addition. We are trying to get the different type of renewable energy sources. We are working on solar. We are working on say the wind and the other sources. The hydro, they have their own limitations because hydro, maximum hydros are working during the say, rainy season only. But the biomass, the other kind of generations, they are not satisfying the requirement. This can be seen over here because the thermal energy or the thermal energy generation is 77.35% and the renewable energy generation is 28.57 mega watts. Billion units, that is 19.37% only. That is 19.37 only. Okay. This renewable sources, these are the renewable sources: large hydro, small hydro, wind, biomass, and solar. At the same time, last time the other, what normally we call it as the other, the Bhutan import hydro. So we are trying to get the water from that, and then normally we are trying to generate the energy. Then this is nuclear, which is very less, 3.24%. Okay, so all these numbers which are given you 114.11, those are in billion units, energy generation, and this is 28.57 billion units. Those energy, that much energy is generated. Now, the renewable energy generation, if we consider in the month of January 2024, that is now I am saying in million units. So that is in January 24, 22,415. In December, it was 27,526. And next, in the January 25, it is 28,572.73. So we can understand that these units energy generation is increasing. Energy generation is in increasing order. But that is not as per expectation, because say in January 2024 it is 22,415 million units, and in January 25 it is only 28,572 million units. So this change is not that much which we are expecting. Hence, it is expected that in future we will try to generate. So we have target of 2030, we have target of 2050, and then there are so many say methods they are adopting for the renewable energy applications to increase the renewable energy application. This is the capacity addition, additional renewable energy generations, January 25 compared to January 24. When we compare it January 25 to January 24, we are getting that the additional renewable energy which is generated in case of wind, it is good. In case of solar, we are getting 3,277 million units. In biomass, in bagasse, in small hydro, in large hydro, and in others, it is the same thing, which we are not getting much more from the others. We are not getting huge amount from the bagasse and biomass, but we are getting small hydros are helping us, large hydros are helping a lot, and solar and wind energy generation, that is the additional generation, is say there is a great change compared to 24 January 24. Now the growth rate, all what calculations we have done, all what the presentation is going on, according to that, the India renewable energy growth rate in percentage increase over the same month, so 24-25. If you compare, then April 24 to April 25, how much increase is there? That is 5.28. In May, that is 9.09. In June, it is reduced. In July, it is a bit good in compared to June, but in August, it is showing negative. Then in September, it is good. Then October, and in the month of January 2025, we are getting a good change, that is 31.88% change is there, that is increase in the say renewable energy generation. Now, finally, I'm trying to show you that the month-wise wind and solar, normally, as already I have shown you that we will try to concentrate on wind and solar. So, in the month of January 2025, day-wise, this shows you the date-wise, how this, you can go through this date, and according to that, how the solar and wind energy generation is changing, that can be seen. Okay, so there is a bit, say, the difference is not huge in the generation day wise I am talking about, but the contribution is good if we compare to the last year. So in January 2025, the daily generation of solar and wind is as per our expectation, but the situation is that we our requirements are increasing. Now, power quality is the most vulnerable issue. Whether it is true or not, we have to have another session for this, because power quality, it has an issue with electrical power since it was invented. When we were trying to utilize it before, earlier people were using the DC power, and when we were using the DC at that time also, the major issue of distribution of energy was taking place, and if it is not properly distributed, then that was creating problems. Uh, this power quality issue is becoming popular in these days. In recent years, the power quality issue is taken care, because there is a huge amount of uses which are increased, or people are trying to use the energy, and they are using the energy for sensible uh, uses, or whatever the instruments we are using. Now see, just I think Thube sir, he has given one lecture now, and in that lecture he was saying that they are shifting to the uh, I think the digital substation. Okay, so if we are going for the digital substation, it is I think nearby the Jalgaon in Maharashtra state only. So if they are using optical fiber there, and again, instead of using those copper wires and all that, there's no doubt, because of that the cost of the total project may get reduced, but they are using the optical fibers, they are using the communication equipments which are very sensitive. They are very sensitive. And if there is a small change in the voltage fluctuation, say voltage surge, because of that, what happens, that they get affected. And at that time, everybody will think about that. Oh, why it is happening? It is because of the power quality issue. Say, so many people are using the PCs, they are using the laptops. It is very common. In earlier period, it was not very common. Now everybody is using the laptops, and there are the problems that if you don't have a regular power, or if there is a power failure for say small intervals, for large intervals, then definitely the loss of data takes place. You can't store it, you can't save it, and then the data may get lost.
त्याचं फक्त डेटा एंट्री
Then
करायचं.
there are so many machines, they will not work properly. In the electrical applications, you are finding it out that if you consider the city like Malegaon or say Bhiwandi, where there are loops, they need a continuous power supply. There are so many applications where they need a continuous power supply, and if the continuous power supply is not there, because of this power quality issue, what are the issues that we are going to discuss? But then that will affect the whole work, that will affect the whole system, and it's a great loss. Okay, so this is becoming a point of discussion for everywhere in these days. That's why I've written this point. Then the power quality problems, according to their impact on the electrical system, they are discussed regularly in these days. Okay. Uh, Now we are trying to discuss the power quality issues. What are the different power quality issues? So I will start with the voltage sag. Voltage sag is one of the power quality issue. you can say that it's a temporary drop in the voltage level, and it affects the equipment, whatever the equipment, whatever machines you are using. Definitely, those equipments will be
Right,
affected. If you are
everything
using in
solved, right?
industry, there will be machines. If you are using
Everything
at
solved,
home, then there
everything.
will be appliances. Whatever appliances you are using, then definitely they may face, say, some kind of problem. So many times we can't understand it. So many times,
ते एक काम करा
if
घडी
there is
3 वाजता
a
करून
huge
घ्या
problem,
पास
then
करा
only
पटकन
we
जा.
understand. Okay,
पास करा.
this
तुम्हाला
this
तीनला
device
जायचं
or
का?
this
तुम्ही आता
appliance
जाऊ
is not
शकता, काही
working.
टेन्शन नाही.
Mm,
हो लवकर जा.
Short interruption.
लवकर जा
That is
म्हणजे
the
पुढचं
second
काम
issue.
व्यवस्थित होईल मग असं. काय
Short
नाही, 2 दिवस
interruption
चालले मी
means
विचार म्हणून फोटो
that
काढून
we can
चालणार.
call it as a brief power
संध्याकाळी
outage.
स्टेटस ठेवली आहे मॅडमनी इथं कचरा वगैरे.
It is disrupting the operations. Okay. So for short interval of time, I will say that less than 2 minutes, more than 10 seconds, if this is happening, then if backup is not provided, if the backup is not available, then your PC will shut down. It will stop. It will close working. And whatever data you have, whatever work you are going to do, or whatever work you have done, that may be at loss. So this is the part which comes under the short interruption. Then there is a long interruption. In long interruption, it is the extended power outage. Extended power outage causes a significant impact. See, for short interval of time, if there is a power failure and again it is restoring, then we can say that there may not be a huge problem. But if a long interruption is there, say power failure for 1 hour, power failure for more than say 2 hours, more than say 30 minutes, then definitely it will hamper the overall working. It will hamper in industry. Just I was discussing about the continuous process industry. So in continuous process industry, definitely the work will get hampered.
इथं दिसते तिथं
Then
दिसते
next one is voltage spike. Voltage spike means
इथं दिसते तिथं
sudden
दिसते.
increase in voltage and potentially damaging the device. So this is a momentary. Voltage spike is a momentary. In that, what is happening? In that scheme, we are finding it out that a sudden increase, voltage gets increased suddenly. So if it is getting increased suddenly for a short interval of time, for microseconds, with a very high amount of voltage going through the system, then definitely it will damage the device. Okay, so it potentially damages the device. Then voltage swell. Voltage
हो भाई
swell
40 रुपये.
is the prolonged voltage
20 लाखचे 40.
increases and it affecting the system performance. Okay, so it's a prolonged voltage increase. So increase in voltage for a large amount of time. Next one is harmonics. If we consider the harmonics, those are the distorted waveforms. And what is the effect of that? It is causing inefficiencies and overheating. We all of we know harmonics. We have discussed so many times what exactly the harmonics is. And as an electrical engineer, I hope everybody must be knowing about the harmonics. The voltage fluctuation, that is the next part. Voltage fluctuation is normally leading towards the voltage flicker. It is normally leading towards the voltage flicker. The voltage fluctuation means rapid voltage change, which is leading to instability, which is leading to instability. And next one is noise. Noise means the electrical interference, that is the disrupting signal which is it is signal clarity is say disrupted. We are unable to get the signal clarity. Now here you will find it out that there are different factors. We can say that the electromagnetic interference, that is one part which is very common, and we are getting the effect of that also. So all these are the power quality issues. We will discuss these power quality issues one by one. Voltage sag. What is voltage sag? I am trying to explain it in short that this is most common problem in which voltage drops from 10 to 90% of the normal power frequency voltage. So there is a drop in voltage from 10% to 90%. Okay, this may last to 1 minute. This may last for 1 minute. Then what are the consequences of that? The malfunctioning of computers. Just already we have discussed about it. The IT equipments, different equipment which normally we are using for the, say, information transfer, we are using for the data cables, we are using for the signal boosting, then electromechanical relays and electrical or electric rotating equipment, they are getting affected because of that. Then what are the appropriate solutions for that? Then using voltage regulator, that is the first part. Then power conditioners, then we can use uninterrupted power supply system that can prevent this damage. Okay, so this is the about the voltage sag. You can get this voltage sag. Just now I have explained you what is voltage sag. Voltage sag means it is a voltage drop. Up to what extent? 10 to 90% reduction. Then duration up to 1 minute. This is for 1 minute. So what are the consequences of that? There is a equipment malfunction. Okay. Then computers and IT equipment get affected. Then electromechanical relays may get affected because of this. And then what are the solutions? We can have a voltage regulators. Normally, in some of the cases, we are using voltage regulators. Then the uninterrupted power supply system is used. Then the again strategies for mitigation of voltage sag. What are the different strategies which we can use for mitigation the voltage sag? We can use utility network reconfiguration. We can reconfigure the utility network. Then we can use this mitigating device, whatever the device we just now we have discussed, those device can be installed and we can control this voltage stack. Then the optimal network topology can be used. Then reduction in voltage sag. Then fewer process trips. That is possible if we can use the tripping system. If the voltage is, say, it is changing drastically, then we can have the trip positions, and we can reduce the financial losses. We can reduce the financial losses because of that. Then next one is short interruption. In short interruption, I will try to show you that what is that occurrence of short interruption. Why it is there? Because of the tripping of protection devices. If the protective devices are getting tripped, then there is say short interruption. What will happen because of that? We will get that inefficient data processing, and at the same time, data loss may take place in this process. Okay. Uh, the stopping of sensitive equipment is essential whenever we are facing this problem. So what we can do, we can implement the power conditioners. We can have the power conditioners. We can control the power. We can use these devices, and we can get effect of it. Then use of uninterrupted power supply system. Use of uninterrupted power supply system can be used. Normally, we people are using in everywhere that UPS. Okay, so that is nothing but the solution of that. Now, for the long interruptions, so long power interruption, you can manage it. So long power interruption occurs when power supply is halted for over 2 seconds. Okay, 2 or more than 2 seconds, wherever it occurs, at that time we are considering it as a power interruption. Then the equipment stop functioning. Because of this, the equipment stop functioning. All electrical equipments exposes or they are unable to operate. Then what we can do, they implement temporary solutions. We can implement some solutions for that. What are those solutions? First one, we can use the generators and we can use the inverters to restore the power. Okay. It is a very common thing nowadays we are using, but say this we are using at certain cost. Hence, to get the power quality or quality power to us. See, in so many cases, it is observed that we don't have say options. Even the people those who are staying in Nasik, we don't have options. We have to use the MACDCL whatever energy they are giving. Uh, have anybody measured the voltage at any time? sir, this is the voltage which I am getting at home. No, we are blindly following them. We are saying that we have faith in, say, NACDCL, and I think Mr. Dubey, he may have some questions on that. But the situation is that we are not going to take whether the quality power is reaching to us or not, and because of that, so many equipments at our house, they may get affected. Okay, but we will get the effect later on. We can't understand it at the same point of time. Now voltage spike, what is happening in case of voltage spike? So this takes at a lightning speed. Voltage spike. Spike means for very short interval of time, very large voltage is coming into picture. And this large voltage, when it is going through or when it is, say, approaching to any component or say device, then the device may get damaged.
तुम्ही काही
So
करा
a
ते
sudden
ठोकणारच.
spike in voltage may occur
कमिटीवाला
due to the
किती
lightning
केलं
strike,
तर
and
ठोकायचीच असते
during
कमिटीमध्ये.
thunderstorms or
त्याच्यापेक्षा ते
during
दिवशी मस्तपैकी
say due to the sudden connection or disconnection, means making or breaking of the contact of heavy loads to the mains or from the mains. So in both the cases it is possible. So these spikes are generally last for few microseconds. Those are not lasting for long time. It is for very short interval of time. What are the consequences of that? The consequences are the destruction of high sensitivity components. So here I will tell you that sensitive equipment damage. So microprocessors and other sensitive components which normally are very common in, say, all the equipment. If you are at home and you are finding out that there is a huge surge, then definitely the washing machine that gets affected. If it is in office, then your fax machine that is getting affected. So these are very sensitive equipment which gets affected because of that. The electromagnetic interference will take place. That will disrupt the electronic operations. So malfunctioning may take place, and the voltage regulators and UPS can be used as a remedy for that. What is the remedy? We can use the regulators and the uninterrupted power supplies for the same. So devices are employed the uninterrupted power supply or voltage regulators, or sometimes the stabilizers. It was very common to use stabilizers few years back. Now also some of the people, they are using in some of the applications, say like AC or in the refrigerator, people are using the stabilizers. Okay, so the devices, they are employed, such devices are employed to stabilize the voltage and to protect the equipment. Now there is the next part which is about the voltage swell. Sag and swell. These are the two reverse, say, parts. Voltage swell, which is defined as a brief increase in the voltage for a few seconds. So this is generally caused due to the defective transformer, inefficient power sources, or sudden operation in the heavy loads. So these are the causes. So what is happening? The voltage swell, it occurs when it is caused by the defective transformer, or it is caused by the inefficient power sources, or it is caused by heavy load operation. Then what we can do? Flickering lights and displays is the consequences of that. The consequences of that are flickering lights and the displays. So many times it happens that we get the light flicker. Okay. Then the data loss. If you are using any, say, computer related system, then definitely it will get affected and you will lose your data. The equipment, if you are using any, I'm saying about appliances or equipments in the industry, they will get damaged. And what are the solutions for that? Then the solution is use of voltage regulator. So you can use the voltage regulator for uh, controlling the voltage swell and impact of that. Now next one is harmonic. I think harmonic is very common part which for an electrical engineer, which normally we are always trying to discuss. Uh, Harmonic distortions are associated with both voltage and current. So though the voltage harmonics are present, most of the harmonics are caused as a result of current distortion. And prominent electrical distortion, it takes place due to the presence of the variable electric load on the power supply. It is also known as non-linear flow. Both are also known as non-linear flow. what are the consequences of that? The consequences are increased resonance. I think, I'm having the diagram. So the consequences are increased resonance, and then the cable overload. So again, heating, again the problem of insulation, because heating will definitely affect the insulation of that cable, and then again there will be a problem of the relatively insulation of the cable. If we are trying to avoid this, then the solutions are, we can have a K-rated transformer, and we can have a passive filter. We can also have the active filters, but that is costly affair. Okay, so active filters, whenever we are using, you will find it out that it's costly. So naturally, we are going for these two solutions. There are so many solutions available, but now we are discussing about these two. What the harmonics are. So you can see that the figure, easily you can check it out. What is the fundamental? Okay, so the fundamental harmonics 50 hertz. Then the second order frequency is 100. Then the third order is 150, and fourth order is 200 hertz. Okay, so these are the harmonics. I have not added it, but there are so many combinations. You can have distortion, different type of distortion, and the combined waveform can be shown. Total harmonic distortion. This is the ratio of the total harmonic component to the fundamental component. Okay. The formula is very commonly known, and it's a very common formula. The numerator of the sum of the RMS values of each order, which is starting from the second order, and the denominator is the RMS value of the fundamental. Okay. Now there are some standards for the harmonics also. So the standards such as 610032 and EN50160 and IEEE 519, all they specify the limit for harmonic content, and or they try to say something about the total harmonic distortion of the each order. Then the limits which are given there, those are classified into several categories, such as power supply voltage, then rated current of the edge. The total harmonic distortion value in the voltage is typically 1% to less than 10%. Okay? As the current, the value may exceed 100% when there are lot of harmonics. Okay? I may have the table. I will try to show you the table. Uh, yeah. So this table one, it shows the recommended values as per the European standard 50160, and the limit values are given to you, fundamental harmonics and second, third, fourth, and all those values are mentioned over here. So this is very common table which shows you that how the order and what are the limit values for the harmonic. Yeah. Next one is voltage fluctuation. When we are discussing about voltage fluctuation, it arises due to the oscillation in the voltage value and amplitude when the modulated by signal waves having frequency less than or equal to 30 Hz. Instead of this, I will try to show you that what are the fluctuations, because it is nothing but the flicker part, which after this we are going to discuss. Uh, Oscillations in the voltage. What means or what leads to voltage fluctuation? Oscillations in the voltage, then change in amplitude, then frequency variations. Wherever there are frequency variations, all these lead to voltage fluctuation. Then high frequency interference, low frequency signal, and signal modulation. Okay, because of this, the voltage fluctuation takes place, and this voltage fluctuation can be considered as flicker. That can be considered as flicker. The flicker is a result of voltage fluctuation. Actually, definition of flicker also we are going to discuss, but there is a variation. So this variation that is given by the General Electric. So, okay, flicker. We will try to discuss about the flicker. What exactly the flicker means. Fluctuations in the supply voltage. Because of that, the luminosity variations of
टोटल सर्व
a
घ्यायचं
light source
म्हणजे वरचं
can
व्होल्टेज
occur, and this
त्याचं
is
काय काय
known
फंक्शन
as flicker.
आहे तसं व्होल्टेज
Okay, so
मेजर
you
कुठलं
can
होतं
see
एसी
that
होतं डीसी
if
होतं त्याची
the light is
रेंज
flickering,
तसं
it is
करंट
not good for you,
रेजिस्टन्स जे
your
काय जेवढे
eyes.
फंक्शन
Okay,
दिलेले
you will feel
त्याच्यावरती
that, oh,
त्याची
please
प्रत्येकाची आणि
try to
मल्टीमीटर
stop
नेमकं
it.
काय आहे
Either
त्याच्यामध्ये काय
you
असतं
have to turn it off. Okay, so this
ते
is the
कसं
flicker.
ओळखायचं असं
Now in the figure, wherever we are getting that figure 17a and b,
कोणतं
in this
मल्टीमीटर
figure,
काय
you will try to find it out that how
मल्टीमीटर
this
कोणतं
the flicker means how the
मल्टीमीटर
change is
कुठला
there. So I have given you that light output, say with respect to time. Time is on the x-axis, and how that change is observed. So this change means peak to peak amplitude. Here you are getting that peak to peak amplitude, and average light output is shown over there. Okay, so you can check it from maximum value is to A and minimum value is B. So what this shows, this say percentage flicker can be given as 100 multiplied by A minus B upon A plus B. This is change A plus B, A and B. So these are the A is a maximum value, B is a minimum value. So A minus B divided by A plus B, and that can be given, or the flicker index can be calculated because of that. Actually, uh, flicker index means so many times we are trying to use the two parts. One is considered as the short time flicker, and another is considered as a long time flicker. Okay, so the duration is either for 10 minutes, and duration for the long time flicker is say 2 hours. So how the changes are taking place in that we are trying to find out, and then we can get the value of flicker calculation or flicker measurement is also a great issue. Now here we are getting in this figure B voltage fluctuation. So these
चार्टमध्ये
voltage
कुठली
fluctuations
कॉर्डिनेट
are
आहे
shown by two parts. One is
सजेशन
square wave, so it is shown by
त्याच्यामध्ये
this
कुठलं
red line.
ठीक आहे
So these red lines, show you that this change is in square waveform. This change is in square waveform, and the blue lines shows you that the change is in the sinusoidal waveform. So in this sinusoidal waveform, this change you can see this V, which was up to this, and here you will find out that this del V. This del V is nothing but change in potential, change in voltage, change in value or change in magnitude. Okay, and that is nothing but the flicker part. Okay. Now this is a common say flicker curve, thermoelectric flicker curve, that is called as. It is say on the x-axis we can see that fluctuations per hour, fluctuations per minute, and fluctuations per second, and here the percentage voltage fluctuation is on y-axis. So this is in between these two lines. Okay, what these two curves shows, the first curve, which I am trying to show you, that this first curve, upper curve, it is a borderline of variation. Okay, and this lower is the borderline of visibility. Okay, so you can see it there, you can see it. So the borderline of visibility and borderline of the variation, that can be seen over here. And as you are moving towards the second, means time period is reducing, we are getting that the fluctuations here they are reducing. Okay, and it can be seen that there is some change at this next part. Okay, so fluctuations per hour, fluctuations per minute, and fluctuations per second. This graph shows it is nothing but the flicker curve. This is general electric flicker curve. Now, as per IEEE 1159, the categories and characteristics of electromagnetic phenomena, we are getting that how much fluctuations are permitted. Okay, so the transients, the categories are given over here in this first part. Categories are there. We can say that the transient, impulsive transient, oscillatory transient, then instantaneous transient, then momentary transient, temporary transient, and long duration variation. After that, voltage imbalance and voltage fluctuation. So when I am talking about voltage fluctuation, so that voltage fluctuation, I have highlighted this by this yellow mark, that voltage fluctuations which are permitted. So spectral content is less than 25 Hertz. The typical duration is intermittent, and the voltage magnitude is say 0.1 to 7. What does it show? That these are the standards. These are the standards as per IEEE 1159. These are the standards for voltage fluctuation which are permitted. Okay. Yeah. Now the when we are discussing about the renewable energy, I am trying to show you that this is nothing but uh, the wind park or wind farm. And in this wind park or wind farm, the number of windmills can be seen. Okay, so there are, you can see that there are feeders, E1 feeder, E2 feeder, E3 feeder, E4 feeder. Okay, then individual wind turbine generators are seen, one, two, three, four, and n number of wind turbine generators are there. Okay, and we are trying to get the uh, output which is connected to this grid. Here you will find it out that grid interconnect point. This is nothing but the grid interconnect point, and the 11 say 11 kV, 110 kV and 110 kV bus bar is there. Okay, so this is a simple layout of the large wind farms of the large wind farms. Now, if I go towards levels of the flicker, then I told you that there is one PST, that is short term flicker, and PLT, that is called as long term flicker. Okay, so short term flicker is for only 10 minutes and long term flicker is for say 2 hours. Okay, so all those calculations or all those readings you have to take, that what are the changes and how the changes are, and then you can define the level of that flickering. So it is crucial to measure the switching operation during cut-in and cut-out speeds of wind turbine. Now, wind turbine have specific characteristics. What is the problem? That wind turbine runs at specific wind speeds only. If the wind speed is very high, then the wind turbines are not rotating and we are trying to halt that. But if the speed is too low, then also the wind turbines are not rotating. So they are having, say, suppose around about 9 RPM to suppose 13 to 15 RPM. This is the range. During this period only, whenever the speed will be in between 9 RPM to 15 RPM, when the speed will be in between these two values, then only the wind turbine will operate and that will give you the generation or that will give you the energy. Okay, so when it stops and when it starts, we will normally consider the cut in and cut out speeds, okay, of the wind turbine. And those are finalized by the again IEC. There are so many relations, but still that is given by IEC 6140021 standard. The issue of flickering is attributed to switching operations, which include startup and shutdown, as well as fluctuations in power output. During continuous operation, it remains a significant concern within wind turbine system. Okay, so the planning levels, we can see this table number 3, which gives you the flicker compatibility and planning levels. So what is voltage level? It is PST. Okay, so that is also called as short term flicker. Then compatibility level, that is low voltage and medium voltage, that is given as 1. And what are the planning levels? Planning levels for medium voltage and higher voltage or extra high voltage. So for medium voltage it is 0.9 and for high voltage or extra high voltage it is 0.8. Okay. Now, how to measure this flicker? Flicker means again the change in voltage fluctuation. So how to measure it? There are also IEEE standards or the international standards. According to IEC 6100-4-15 or IEEE 1453-2022 110, a flicker meter model is developed to calculate the short-term flicker severity index, that is called as PST. Okay, short-term flicker severity index, and the flicker meter architect, which described by the say, I will try to show you this block diagram, and yes, this is the block diagram which we are trying to get. So in this, we are trying to measure this voltage. Okay, so voltage adoption and simulation of the response of the say, lamp eye brain chain and online statistical analysis of the flicker signal, and which is presentation of the result. So flicker meter is a common part. Now the input waveform which we are getting here, this is demodulated while carrier signal is removed in the first section, and in this process of DC offset and high frequency terms are produced. So it is in short, I will try to show you that in block 1 we are trying to detect and get the gain control. Then we are trying to the where low demodulator is there in block 2. In block 3 it is the demodulator filters are there. Then we are trying to wait. After that the ranges are fixed. Then in block 4 we are trying to get the squaring multiplier, and with the help of that a first order low pass filter is there, which gives you the signal to the analog to digital converter. Then that is classified, and then output is given in terms of that flicker severity, that is whether it is PST or whether it is PLT. Okay, so this is how this flicker meter is based on the Rasbas model, and we can say that he has already given some additional part, and this is available in say PSCAD. We can use that, and we can find it out that what exactly the change in the voltage level is. Okay. Now the wind energy conversion system, power quality issue which is observed in case of wind energy conversion system. So earlier what we have seen that the uh, this wind farm, this wind farm for a single individual wind turbine generator, there will be such a kind of system. And when we are getting this system, at that time we will find it out that the overall working of this overall working and this sinusoidal, this is the source generator. After that, there are so many issues which are taking place. Okay, now there may be linear load as well as non-linear load. So non-linear load means SMPS, AC drives, fluorescent lamps, etc. So at the point of common coupling, we will find it out that this energy which is provided to all these loads, okay, that energy is provided to all the loads. Then harmonic voltage distortion, which is imposed by the other customers and customers with linear load. So some customers may have linear load, some customers may not have linear load, but their load may be a non-linear, and because of that, the system will get affected. Okay. Now, next part after this say flicker or voltage fluctuation, next point is noise. What is noise? Okay, so we are analyzing the noise in power system. It is frequency interference. Noise means, in short, noise means unwanted signal. Noise means unwanted signals. So frequency interference, higher frequency signals, and frequency superimposition. Okay, after that, what are the mitigation techniques? Bypassing methods, we can use bypass filters. Then filtering technique, we can filter that signal so that the noise will not be there. Then electronic disturbances, what are the consequences, or what are the effects of this noise? Those are electronic disturbances. The IT equipment, they are sensitive equipment, so the sensitivity changes. Sometimes they may not be working properly. Sometimes the equipment get disturbed. Sometimes the equipment get damaged because of the noise. But here we are considering that noise means a very small unwanted signal is there. If the unwanted signal is large, then definitely the total system will get affected, and we are trying to disturb the whole power system. The voltage unbalance. Now, what is this voltage unbalance? So, what are the effects and what are the benefits of voltage unbalance? That I am trying to say is that it mitigates negative signal. Okay, then they protects the phase loads, and the voltage unbalance, it enhances the system stability. Now, voltage unbalance is harmful to the induction motors, because definitely the if the voltage is imbalanced in the three phases, then definitely the motor will get affected, the working will get affected, the speed, everything because of that. And finally, since it is a motor, the outcome is in terms of the rotational speed. So that rotations or the speed will get affected, and if the speed gets affected, the whole system which is working on that motor shaft, which is connected to that motor shaft, definitely that will also get affected. Now, what are the causes? The causes equipment stress. If we will find it out that voltage is getting unbalanced, we have seen that unbalanced voltage in case of so many calculations or in so many devices, which we are discussing in case of transformer, say, induction motor, synchronous motor. So it causes the equipment stress. And what we need, it needs, it requires investment. Okay. Now, the brownouts is a continuous low voltage power supply state. This state is a continuous low voltage power supply. It occurs in summers. Maximum it occurs in summers. What are the consequences of that? Insufficient data processing or loss of data and malfunctioning of the electrical equipment. So it is a continuous low voltage process. What are the consequences of that? The consequences, it includes the inefficient data processing. Inefficient data processing. Then there may be a data loss and there may be a malfunctioning of electrical equipment. Now the question is that what solutions can be provided or to prevent from that? The voltage regulators we can use. We can use the uninterrupted power supply and power conditioners which can protect your electrical equipment from brownouts. Now here I am coming to the conclusion part where we are trying to discuss about the power quality problem. Is the from the inception the power quality problem is there, that already I have told you that many measures were taken to control the loss of power when distributed over long distances, such as attenuation and polarization. The unfortunately even now the problem persists, so we are unable to nullify that problem. However, we can reduce, if we cannot eliminate, we can reduce that problem and the power quality problems with the above all mentioned electric equipment as solution to this problem. So here we can say that if we are using voltage sag, the solution is the devices to mitigate the temporary voltage drops. Okay. Then short interruptions, the solution is equipment to minimize brief power outage. Then, in case of long interruption solutions, is we can have the strategies to address the extended power interruption. If we have voltage spike solution, then we can use the tools to protect against sudden voltage increase. And voltage swell solutions are the same methods to counter temporary voltage surges, and harmonic solutions. We know that solutions to reduce the harmonics, we are using the K transformer, okay, and the system distribution, we can make it properly so that the harmonics can be reduced. Okay, so the next one are the references, the linked. So I think, yeah, sorry, yeah, these are the references which you can go through. Normally, I have gone through the uh, electrical, this part, which every time I am trying to mention you that from where I am taking this data, and that data is readily available. Anybody can use that data part, where the Central Electrical Authority. Even you can get some part from the MNRE site also. The Ministry of Renewable and Non-Renewable Energy Sources. They are trying to give you some data. They are trying to give you the planned working situations also. Okay? So thank you. I'm very much thankful to the management that they have given me a chance. Principal, Dr. Deshpande ma'am. I'm also thankful to the organizing committee. I'm thankful to my college management and my college principal, Dr. Chandratre sir, for giving me this opportunity. Uh, if you have any questions to be discussed, please. Yes? Anyone is having any questions? You can put it in chat box also.
कोणाला काही
कोणाला
डाऊट्स
काही डाऊट्स
असतील तर
असतील तर
विचारू
विचारू
शकता.
शकता.
Yeah, I think there is
उद्याची मीटिंग आहे ना.
Professor Shinde. He want to ask wind from Tamil Nadu. Yes. What is the question? I am not getting it. Please unmute yourself and you can say.
हा सर, तुम्ही स्टार्टिंगला क्वेश्चन विचारला ना,
Ha.
which
Okay.
energy is
Okay. Yes. Yes. Any other
आहे ना
question?
सर.
Any other question?
नो.
Okay. So thank you to the team and congratulations that you are arranging such events. So thanks a lot.
Thank you so much, sir, for this wonderful session. I am sure all participants have gained incredible knowledge and ideas from this session. All participants are requested to fill the feedback link for today's session. It is provided on WhatsApp group. Please fill the feedback. Thank you once again
Okay,
to everyone.
thank you very much. So should I leave, ma'am?
Thank you so much,
Yes, sir.
Yes
everyone,
sir,
for
thank you sir.
joining.
Thank you.
We look forward to stay connected on Monday at 11 a.m. for the next session of day 3. Thank you. Have a great day ahead.
सर रेकॉर्डिंग स्टॉप करायला लागलं. थांबा.